So the next force on our laundry list of different forces we want to learn about is known as the tension force. This is kind of a generic name for a very commonly occurring force all throughout everything from architecture to the human body. So what is a tension force? First of all, it is basically a pulling force that is caused by stretching something. And that something could be anything from a rope, a rubber band, a steel beam, a piece of wood, or it could be a tendon or something like that within the human body. So all different materials all around us have this property where if you try to stretch them out, if you take this and try to pull it apart, it pulls back at you. And that's basically the tension force. So we're not going to worry much at this moment about trying to explain what the tension force really is. Let me just give you kind of the 10-second version of that. It basically results from trying to stretch out the bonds between atoms when you try to stretch out the material. So as you know, if you take like two atoms and let them form some kind of bond, there will be a certain distance where that bond is happy and where that bond is linked up with each other. And if you try to pull those atoms apart, they will resist and they will try to come back together because there's a force holding them together. So that effect is basically multiplied by kind of Avogadro's number when you have a real material and you try to stretch out a real material and all the atoms are getting pulled away from each other. They're all going to pull back and give you this force that we generically call tension. We are not going to make any attempt right now to try to model this on the microscopic level or even write down a formula at this moment for how you calculate the tension force. So at this point in time, there's not any force to plug into to calculate the magnitude of the tension force. Just like with the normal force we've already encountered and with the static friction force we've already encountered, just include it in your F equals ma equations as an unknown variable and solve for it that way. The only thing you do need to know about the tension force is that the direction, since it's a pulling force, the direction will be in, direction is in the same direction as the material that is doing the pulling, which is very simple, very straightforward. So for example, continuing the theme of doing everything with toys that I have around the house here for my daughter, like this little fishing rod toy here. We have a string that connects the tip of the fishing rod to the fish I've caught here. And like, what is actually holding up this fish? And the answer is that this rope here is getting just very tiny amount of stretch from the weight of this thing pulling down. And so the string is pulling back upwards. And so if you were to free body diagram this thing that's hanging here, what you would end up getting here. So here's my, fish that I'm catching on the fishing rod. You would get the gravitational force is pulling downward, and you would get a tension force going upwards. And those would be opposed to each other. And so the tension force would be providing that upward force. So this would be the tension force. I usually call it T. Some people like to use F sub T, which is also totally fine. Actually, maybe even better, but I just got in the habit of calling it T. So you have the tension going up, the gravitational force going down. So you would have then, in this case, T minus mg equals ma if the object is accelerating or, whatever the case may be. So you would just handle it something like that. And then if the rope is in an angle somehow so that it's getting pulled, like maybe I pull it in this direction. So now the rope is at an angle. Now the tension force is also at an angle because the tension force will be at the same direction as whatever direction the rope is in. And it's just that simple. That's all there really is to know about the tension force. Most of the tension force is just going to be seeing some examples and getting used to solving it.